This is Mt John's 1 metre telescope, McLellan Telescope, named after Professor McLellan, who was head of department when it was built. It was largely constructed in workshops at the Department of Physics and Astronomy at Canterbury University in the early 1980s. It was designed very much by Graham Kershaw in consultation with people in the engineering department at Canterbury University. He and Maury Polton primarily worked on it over several years till 1985. The mirror, the 1 metre mirror that collects the light, was ground and polished by Gary Nankerville from what was then the optics department of the optics division of the Department of Scientific and Industrial Research in Lower Hutt. Gary set up a grinding polishing machine in the workshops at Canterbury. He also made the secondary mirror. There are two secondary mirrors for this telescope, I'll explain in a moment, that go at the top. The telescope is on what we call an equatorial mount. It has one axle aimed at the south celestial pole, or if you like to think of it another way, it has an axle parallel to Earth's axis. And we keep the telescope tracking on the sky by rotating on that axis at one turn a day. We can change the focal ratio of the telescope. When we're doing spectroscopy, which is what it's set up to do now, we want the light of just one star to be focused onto the end of a glass fibre, and that's achieved with beam splitters and a camera and so on in this box here. And the light is then carried in a glass fibre through the cable into a big spectrograph, which is in a temperature-controlled room off the foyer. If we want to image an area of sky, on the other hand, we don't want to run at this focal length, which is f13. We want a shorter focal length, so we can remove that secondary mirror, rotate the top end around, and attach a much larger secondary mirror. We also, the tube that goes up through the main mirror that baffles out the skylight, that has, when we work it with the other system, it has lenses in it. So the telescope then becomes an f8 system, and that shows us much more sky. So on our CCD that we use for near-Earth asteroids, that has a CCD, sort of digital camera chip, 25mm square, and so working at f8, that shows us a piece of sky about 11 minutes of arc wide. That's about 1/3 of the diameter of a full moon. So we can use the telescope at two different focal ratios.